Myopia, 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 myopia. Near distance we can see far distance we can see myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, hypermetropia. For the correction we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, hypermetropia. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance are positive along the incident is distance are negative. Opposite to incident is distance are positive. Above the principal axis distance are negative. Below the principal axis. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the incident is distance are negative. Opposite to incident is distance are positive. Above the principal axis distance are negative. Opposite to instant race. Say with me, learn with me, sing with me. Dispersion, dispersion. Say with me, learn with me, sing with me. Dispersion, dispersion, dispersion. Splitting a white light into 7 colors is known as dispersion. Splitting a white light into 7 colors is known as dispersion. The band of colors is known as spectrum. Refraction of light takes place by atmosphere is known as atmospheric refraction. The phenomena of re-emission of light in all directions with a different intensity is known as scattering of light. Say with me, learn with me, sing with me. Dispersion, 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 dispersion. Splitting the white light into 7 colors is known as dispersion. Dispersion. Myopia, 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 myopia. Near distance we can see her, far distance we can't see her. Myopia, myopia, myopia. For that correction we are using concave lens, 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 concave lens. Myopia, myopia, myopia. Near distance we can see her, far distance we can see her. Myopia, myopia, myopia. Okay, so like that, so we are now we are discussing the myopia. So myopia, hypermetropia completed, and we completed also magnetic effects of electric current also we completed. So just before, okay, Tanishka, how are you? Welcome to the class. Good evening. Now we are going to discuss about light reflection and refraction. Light reflection and refraction. Light reflection and refraction. CBSE grade 10 physics. Light reflection, reflection and refraction. Light reflection and refraction. Refraction. CBSE grade 10 physics. CBSE grade 10 physics. Okay, CBSE grade 10 physics. So hi everyone, welcome to the class. Dispersion, splitting of white light into 7 colors is known as dispersion. Okay, so when light passes through the prism, it's split into 7 colors. It's constant colors, that is known as dispersion. Splitting a white light into 7 colors is known as dispersion. Yes or no? Dispersion. Okay, so I'm taking the plane mirror. Plane mirror, plane mirror, plane mirror, plane mirror. Highly polished smooth surface is called. A highly polished smooth surface is called plane mirror. Plane mirror. Plane mirror. Plane mirror. A highly polished smooth surface is called plane mirror. So I'm taking incident ray. Incident ray. Incident ray. This is incident ray. The light which is incidenting on that. So reflected ray. Incident ray, reflected ray, incident ray, reflected ray, normal line, normal line, normal line, normal line, incident ray, reflected ray, normal line, 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 incident ray, reflected ray, angle of incidence, 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 students? Yes. So the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. So here I'm considering, from laws of reflection, 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 angle of incident ray, reflected ray, normal line, incident ray, reflected ray, normal line, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So now you are considering, these are the two laws of reflection. Two laws of reflection. Angle of incident equal to angle of reflection. That is nothing but, so we can consider angle of deviation. So the linear angle is 180 degrees. Linear angle is 180 degrees. Linear angle is 180 degrees. Now angle of incident. So here I am considering in this linear pair. So in this angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. So here you can observe here. Okay, so angle of incident plus angle of reflection plus angle of deviation. Angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. From laws of reflection, we know angle of incident equal angle of reflection can be written in the form of angle of incident, angle of reflection. So here angle of incident plus angle of reflection. Now you are considering here. Now I am considering here. Okay, so now you can see angle of incident plus angle of reflection, angle of incident plus angle of deviation equal to 180 degrees. Angle of incident plus angle of deviation equal to 180 degrees. We know that angle of reflection equal to angle of incident plus 2 angle of incidence plus angle of deviation equal to 180 degrees. From this, angle of deviation equal to 180 minus 2 angle of incidence. So 2 angle of incidence. Angle of deviation equal to 180 minus angle of deviation equal to angle of incident is equal to angle of deviation equal to 180 minus 2 angle of incident. So we can also take angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. I hope it is very clear to all. So just check once here. Okay. So normally you can observe here. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. So I'm taking incident ray, reflected ray, normal line. Okay. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. Okay. So loss of reflection means incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident equal to angle of reflection. So we know the linear angle is 180 degrees. So angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. So from laws of reflection, so angle of incident equal to angle of reflection, angle of incident equal to angle of reflection, angle of incident equal to angle of reflection. So angle of incident plus angle of incident plus angle of deviation equal to 180 degrees, 180 degrees, 180 degrees, 180 degrees. So angle of two angle of incident plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to angle of deviation equal to angle of deviation equal to, so 180 minus 2 angle of reflection also we can write. Angle of deviation equal to 180 minus 2 angle of reflection also we can write. We can also write angle of deviation equal to angle of okay. So from laws of reflection, angle incident ray reflected a normal line, angle of incident equal to angle of reflection. So from this we can take, so angle of deviation equal to 180 minus 2 angle of incident, angle of deviation equal to 180 minus 2 angle of reflection. Okay. So now we can go for one more. We can go. Okay. So I am working on it. So 11th grade physics. I planned. So I am taking classes at 6 p.m. So I'll continue. Uh, Okay, so I hope it is very clear. Next, we are going to the next one. Next one, regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection, irregular reflection, 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 regular reflection, irregular reflection. Come on. If the light ray passes along the normal line, if the light ray is passing along the normal line, if the light ray is passing along the normal line, if the light ray is passing along the normal line, if the light ray is incidenting along the normal line, the light ray is incidenting along the normal line. So if you are taking here, so you wanted this. Okay, so you want that, right? You want reason for this, all background of all these things. So Sabir, just go to the videos of mine. Check once my YouTube channel videos, playlist and everything. So you can observe why I'm doing all these things. So definitely you'll get to know. Check my YouTube channel. So check all the videos, you can check. Sabir, I'm telling to you, just check all the videos. Then you will get to know the reason behind of this, why I'm doing all these things. So once check the channel, you will get to know. Okay, next one, regular reflection. Regular reflection. I'm taking the regular reflection. I'm taking the plane mirror here. Plane mirror. I'm taking the plane mirror. Okay, so incident ray is so incident ray, these are incident rays. Okay, these are the incident rays. So these are the reflector light rays. These are reflector light rays. Okay, so incident light rays are parallel and also reflector light rays are parallel to each other. Incident light rays are parallel if reflector light rays also parallel. Incident beam is parallel, then reflector light rays also parallel to each other. If incident light rays are parallel, reflector light rays also parallel. Incident beam is parallel, then reflector light rays also parallel. Then this type of reflection is called regular reflection. Regular reflection. Okay, so I'm considering now. Just 1 minute. 1 minute. Okay. So you can check all the videos. See, those who wanted to know the reason behind of all these things, just you can check my channel, YouTube channel, videos, everything. So you will only get to know all the things. Okay. Just 1 minute. I didn't run off. I updated the version. Updated version. Okay, so everything we need update, right? So these are the updated versions. Okay, so incident rate is, so these are light rays are incident. So after that, reflector light rays also parallel to each other. Incident beam and reflector light rays are parallel to each other. This type of reflection is called regular reflection. Coming to irregular reflection, irregular reflection, irregular reflection, irregular reflection, irregular reflection. Come on. So I am taking here irregular reflection. When the light rays are incidenting on it, so if the light rays are incidenting on it, okay, so I'm taking incident beam is parallel, but reflected light rays are not parallel to each other. In this case, incident beam is parallel. Whatever the light rays I'm taking here, incident beam is parallel. Okay, so now you can consider irregular reflection. Irregular reflection means incident beam is parallel but reflector light rays are not parallel to each other. Incident beam is parallel but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. This type of reflection is called irregular reflection. This type of reflection is called irregular reflection. Okay, so irregular reflection. Next, we'll go to the object and image. So here, related to this one, I will ask two questions. The questions are: if the light ray is passing along the normal line, what is the angle of incident and what is the angle of reflection? What is the angle of incident and what is the angle of reflection? So incident ray, reflected ray, normal line, angle of incidence, angle of reflection, angle of deviation. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Okay, so next we are going to the next one. Come on. If the light ray is incidenting on the surface, along the normal line, if the light rays are incidenting, if the light ray incident along the normal line, what about reflected light rays? What is the angle of incident? What is the angle of reflection? What is the angle of deviation? Now I will discuss. So angle of incidence is 0, angle of reflection is 0, angle of deviation equal to 180 degrees. Come on, 180 degrees. If the light ray incident along the normal line, so I'm considering here I'm considering here. I'm considering here. Considering. Dun, 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 dun. Angle of incident is 0, angle of reflection is 0, angle of deviation is 180 degrees. 180 degrees. Very, very important. And one more question. One more question I will ask. One more question. The question is, a wall reflect the light rays. A wall reflect the light rays and a wall reflect the light rays. Okay, so a wall reflect the light rays. A wall reflect the light rays. A plane mirror reflect light rays. A wall reflect light rays. A wall reflect light rays. A plane mirror reflect light rays. What is the difference between wall and the reflection takes place on these two cases? Plane mirror reflect the light rays. So regular reflection takes place on the plane mirror. Regular reflection takes place on the plane mirror. Regular reflection takes place on the plane mirror. On wall, irregular reflection takes place. So on the plane mirror, regular reflection takes place. On plane mirror, regular reflection takes place. On wall, irregular reflection takes place. Irregular reflection takes place. Okay, so this question is very, very important. And coming to the one more question is related to plane mirror, still water, cardboard, and cinema screen. So what type of reflection will take place? So still water, regular reflection, plane mirror, regular reflection, cardboard, irregular reflection, and one more thing, cinema screen, irregular reflection. And one more question is there. Which type of reflection leads to the formation of images? Which type of reflection leads to the formation of images? Regular reflection. Regular reflection leads to the formation of images. Formation of images. So related to plane mirror, and related to this one. And what is the angle of define angle of incidence? Angle of incidence is nothing but the angle between incident ray and normal line. What are the laws of reflection? Laws of reflection. Incident ray, reflected ray, normal line lies on the same. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. And the second one is angle of incident equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So that is about two laws of reflection. And one more conditions, one more example we can say, angle of deviation. So angle of deviation formula. Related to angle of deviation, questions will ask. Angle of deviation equal to okay. So definitely I will follow Balaji Kaushari like that. Balaji, thank you for your session. Definitely I'll implement. I'll try to follow. Definitely. Okay. So now one more example we are going to that. One more example is already related to angle of incident and angle of reflection. And one more question. So how can you arrange two plane mirrors? How can you arrange? So how can you arrange two plane mirrors? How can you arrange two plane mirrors? So in such way that so incident ray, reflected ray will be always parallel to each other. So question number one is so incident ray, reflected ray always must be parallel to each other. So for that, how you will arrange two plane mirrors? How you will arrange two plane mirrors? How you will arrange two plane mirrors? So if you arrange two plane mirrors perpendicular to each other, if you arrange two plane mirrors perpendicular to each other, I'll draw the diagram. So just check once here. So I'm taking here. So this angle of incidence, angle of reflection, this is the angle of incidence and angle of reflection. So this is the incident ray, incident ray, incident ray, incident ray. This one is the reflected ray, reflected ray. So incident ray, reflected ray will be always parallel to each other. Hare boss, Rohit edits. Really amazing, boss. Yeah, see. Okay, definitely. I'll try. I'll try to take classes. I'll try to take classes in Telugu also. I'll try to allot one more class exclusively for those who want to listen in Telugu language. So definitely I'll start. Definitely I'll start. Okay. So now you are coming to the next one. Coming to the next one. So I'll start. So we'll see soon. Soon I'll start. As of now, I'm teaching in English, so it will be for overall all. So we'll start again. Okay, I'll start. I will let you know soon. Okay. So keep watch my videos. You can check the videos. Okay, you can go through the videos. So next one. I'm going to the next one. So incident ray, reflected ray. So I'm to incident ray, reflected ray, and normal line. Incident ray, reflected ray, normal line. So in this case only, always incident ray and reflected ray, always incident ray and reflected ray parallel to each other. Always incident ray and reflected ray parallel to each other. Always incident ray and reflected ray parallel to each other. So this is very, very important question. This is very, very important. And the next one we are going to the one more. I'm going to the one more question. So that is so regular reflection, irregular reflection completed. Regular reflection, irregular reflection completed. Regular reflection and irregular reflection. Regular reflection and irregular reflection completed. Next, object and image. So object and image, I'm taking this one plane mirror. I'm taking the plane mirror like this. Okay, so this is the object, real object. I'm taking real object. How many light rays are required? So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays. How many light rays are required to form the image of the object? Minimum 2 light rays, right? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays. So I'm considering here 1 light ray I'm taking like this. After incidenting like this, or here also. Okay, so after that it will be reflected back. This also reflected back. So if you are extending these light rays, those light rays will meet at one point. So here image is forming. Okay, so here image is forming. Now you can see this is a real object and virtual image. real object and virtual image, real object and virtual image. Okay, so and one more I'm considering here, one more I'm considering like this. Okay, how now we can take object. So light rays are coming from infinity. Light rays are coming from infinity. One light I'm taking like this. I'm taking like this. Okay, and here I'm considering like this. Okay, so after incidenting, those light rays will meet at one point. So incident ray, reflected ray. If you are extending this light rays, if you are extending this light rays, so this is the real image. Real image, this is the virtual object, real image and virtual object, real image and virtual object. This is the real object and virtual image, real object and virtual image, real object and virtual image. Okay, so when light rays falls on it, okay, I'm taking here. By this one we can conclude that. By this one we can conclude that. So object, image, object and image. So here from this one light rays are coming. From this one light rays are incidentating. After that those light rays are reflected back. If you are extending this reflected light rays, if you are extending this reflected light rays, those light rays are meeting at one point on the principal axis. Those light rays are meeting at one point on the principal axis. So you can see these light rays are, this reflector light rays are meeting at one point on the principal axis. This reflector light rays are meeting at one point on the principal axis. This reflector light rays are meeting at one point on the principal axis. Okay. So here you can see, so this reflector light rays are meeting at one point on the principal axis. One point on the principal axis. Now you can observe this is a reflected light ray, this reflected light ray. Those are reflecting and incidenting at one point. So here image is forming, that is a virtual image. That image is called virtual image. That image is called virtual image. That image is called virtual image. Okay. So next, so these are the reflected light rays. These are the reflected light rays. So after incidenting, light rays are meeting at one point. After incidenting, after reflection, those light rays will meet at one point. After reflection, light rays are meeting at one point. Their image is forming. This is a real image. So if you are extending this incident light rays, incident light rays are meeting at one point on the principal axis. Incident light rays are meeting at one point on the principal axis. Incident light rays are meeting at one point on the principal axis. Their image is forming. So that is a virtual object. Virtual object. So incident light rays are extending. Incident light rays are extending. Those incident light rays are meeting at one point. Those incident light rays are meeting at one point. Their virtual object is forming. Virtual object is forming. Virtual object is forming. Virtual object is forming. Is it clear? And here, so reflector light rays are meeting. Reflector light rays are meeting at one point. Reflector light rays are meeting at one point. Reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Virtual image. Okay. So if the object is real, from this one we can conclude that if the object is real, image is virtual. Object is real. Object is real, image is virtual. Object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Okay, so this is about object and image. Object and image. Object and image. I hope it is very clear to you all. So object and image. Object and image. One object is real. So object is real, image is virtual. Object is virtual, image is real. Once again, object is real, image is virtual. Object is virtual, image is real. I hope it is very clear to you all. Once again, object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Okay. So the point of intersection of reflector light rays are meeting. Their image is forming. That is a virtual image. So here, if you are extending this incident light rays are meeting at one point. Incident light rays are meeting at one point. Their image is forming. That is virtual object. Okay, so we'll go to the next one. Object is real, image is virtual, object is virtual, image is real. Next one, you are taking the plane mirror. So I'm taking the plane mirror. Okay, so I'm considering here object I'm placing here. This is the object, one light I'm taking like this. So incident ray, reflected ray. One more light I'm taking like this. So these are the reflector light rays. So A dash and B dash. A dash and B dash. So here I am considering first one, object is real, image is virtual. Object is virtual, image is real. Point number one. Point number two is so object distance is equal to image distance. Object distance is equal to image distance. Second one, height of the object is equal to height of the image. Height of the object is equal to height of the image. And third one, it also shows lateral inversion. Lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So the phenomena of converting of left side of the object appears to be right side of the image. Right side of the object appears to be left side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. So until here we discussed. So next we'll continue at so around 9:45. Around 9:45. 9:45 again we can join to the class because so dinner break. So you can take dinner break. You can have dinner and come. So I'll be giving 1 hour break. So 8:25 to 8 now 8:30 almost 8:26. 8:26 to 9:26 1 hour. And so like around 9:45 I'll start around 9:45. So 9:30 to 9:45 around that time I'll start. So 9:45 fix it. 9:45 fix it. So join at 9:45. So we'll discuss more points. Still we'll continue from it. From this onwards we'll continue the next topic. So until then, bye. Thank you. See you.